Okay, let's look at our multiple choice questions. Number 1 asks, which describes the graph that moving y equals absolute value of x to the left 3 and up 2. Alright, left goes in the parentheses and it's opposite, so it should be a plus 3. Up 2, that goes outside the parentheses or outside the absolute values, should be a plus 2. So it feels like our answer should be B. You can graph that in Desmos. Absolute value x plus 3 plus 2. And if we're moving it from y equals absolute value of x, it would have started at 0, and then from 0 it went left 3 and up 2. Number 2, what are the solutions to that equation? The way to solve it algebraically is to take the equation, get rid of the absolute value signs, and write it exactly the way that it's written. The other way is to write it without the absolute value signs and then change the sign there and then solve the two equations. We're going to add 1 on both sides, divide by 3. Same thing here, add 1 on both sides, divide by 3. And so our two answers should be -1 and 5/3, which is A. On Desmos, again, we could solve that by doing absolute value. Let's get rid of what we had. Absolute value, 3x minus 1. And because it says equals 4, we're going to move that 4 over and do minus 4. Just figure out where it crosses the x-axis, -1 and 1.667. If we put a whole bunch of 6's in there until our fraction comes back, it will change it to a fraction for us, and we are correct. Number 3, evaluate this function. It says to figure out what f of 2 is. Alright, when I look at the x's, it says x is less than -1 and x is greater than -1. 2 is greater than -1, so I'm going to put my 2 right there. I'm going to have -2 times 2 minus 5, -4 minus 5, which is -9. Alright, number 4, we're looking at a graph. We want to evaluate f of -1. So I go to -1 on the x-axis, and then I find the y value at that place. There's an open circle here. It cannot be that one. It would have to be this one. And so it's a little more than -2, between -2 and -3. The only choice that works there would be B. Alright, number 5 is talking about the quadratic formula. And if you remember the quadratic formula, we do need to know A, B, and C. A is understood to be the number in front of x squared. B is our coefficient of x, and C is our number at the end. So we're going to start off with -b, which means we're going to change that sign. And then we're going to do the square root of b squared. B squared will always be positive, so I drop that negative. Minus 4ac over 2a. Next thing I'm going to do is put the part underneath the square root into Desmos. So 5 squared minus 4 times 1 times 1. We got 21. And that right there will give us our answer, and we get A. Now, you could have graphed this to try to figure it out, and you could find the zeros. First of all, that right there would help you eliminate C and D. Our choices would be A and B, and so if you wanted to put in A, we would say 5, do the positive one, and divide by 2. There's one of our decimals. Let's see if that matches up. Well, if I would have put that in correctly, I didn't put that divided by at the right place. There we go. And let's look at our choices again. Yes, one of those match up with that, so it does seem that that should be the correct answer. And you could check that with B as well, but we know for sure it's not C and D because C and D would not cross the x-axis. All right, the next one wants to know what the remainder of this is when we divide. This is a synthetic division kind of problem. We're going to change the sign of that, put that in our little box. Notice we're missing the x squared term, so we would put a 0 where the x squared goes. And then we bring down our 1. We multiply, add, multiply, add, multiply, and add. Our last number is our remainder, so 3 is our remainder. We could also evaluate the function at -2 by plugging, because -2 is what we divided by. -2 is what you can plug in for x. That also gives us the remainder. There's the check that we can use for that question. Number 7 says, what's the zeros of the function? Anytime I see zeros, I know that I want to graph it and find out where it crosses the x-axis. So I'm going to put it in Desmos right now. And I'm going to look for the zeros that I can find. We've got a -1 and we have a 3. Alright, so looking at our choices here, we know we have a -1 and a 3. It doesn't look like it can be those two choices, so it's got to be one of the last two. What you do there is to start off with division, and the values we get on Desmos, that's our first thing that goes in our box. We do not change that sign. We're going to put our coefficients here, bring down our 1, multiply, add, multiply, add, multiply, add. Then we take our next number, which was 3, we're going to divide again. Multiply, add, multiply, add. And then we do the quadratic formula with those numbers that we just got. This is A, B, and C. B is 0, so that's nice. So we just have plus or minus square root B squared 0 again, minus 4AC over 2A. Alright, that would be a -16 underneath the square root. Square root of -16 is 4I. Divide by 2, and we get plus or minus 2I. So looking back at our choices, we know it must be C because it's not plus or minus 3I. Alright, number 8 says one of the roots is 1. What are the other two roots? If you would graph that, you would find that it would cross the x-axis at 1, and it's just wanting us to do kind of what we did earlier without having to do as many processes. So 1 still goes in the box, and we divide 1, 1, -2. Actually, we've got to have a 0 here because we're missing that x term. And then -2. Bring down the 1, multiply, add, multiply, add, multiply, and add. Again, this is A, B, and C when we do the quadratic formula. So we'll have -b plus or minus square root b squared minus 4ac over 2a. I'm going to multiply out or work out that part underneath the square root. So that would be 2 squared minus 4 times 1 times 2, which is -4. So -2 plus or minus square root -4 over 2. So that's -2 plus or minus 2i over 2. All the 2's will cancel, so -1 plus or minus I. And looking back at our choices, that means our choice answer was A. Okay, on to some rational equations. This is where you have to factor. On the top, there's not much to do with the first one. X plus 3 stays the same. X squared minus 4 is the difference of two squares. You can put x squared minus 4 into Desmos. find the zeros, and change the sign. This is a keep, change, flip problem because it's dividing, so when I change it to times, I do need to flip that. X plus 7 will go on the bottom, but I do need to factor the other part. I'm going to put it in Desmos because that's the way we have been factoring. We find the zeros and change the sign. So you would get X plus 2 and X plus 7. At that point, we can get rid of some X plus 2, some X plus 7s, and that means we're left with X plus 3 over X minus 2, and our answer would be D. All right. Our next question is asking us to look at two graphs and figure out what translation will transform the graph of F into G. So we're trying to move F and make it to G. One thing we can do is graph it. It might look kind of crazy because these are rational functions, but I bet we can figure it out. Alright, so I'm moving the purple to the black. It looks like it's just shifting to the left. Everything says 1 here, so it looks like we're shifting to the left 1. And that makes sense because we're adding another value on the bottom, and adding a value is shifting it to the left. Alright, next it asks for the domain. Most of the time when you see domain and range, we're going to want to graph it so that we can see the graph. And when you're talking about domain of rational functions, it's everything except wherever the vertical asymptote is. I'm going to graph a vertical asymptote. Let's just say it's at 1. Click off of it. Now I'm going to move it over to where I think that it might be. That looks not quite there yet, trying to get there. Looks like 7 would work. It's really close on the ends and it's in the middle. So it looks like the domain would be everything except for 7. And one way that can be written is like D. That means all X values except 7. Alright, number 12. Which equation represents exponential growth? You can graph those to determine which one gives you exponential growth. I will remind you, if you look at the values in the parentheses, you want those values to be bigger than 1. The one that's bigger than 1 is this one. So it appears that our answer would be B. If we do graph that, we would have 1/2 times 1 plus 1. That does need to come outside of that fraction to the X. And I can look at that and I can tell that that is growing, so that one must be correct. Number 13. On Desmos, I would again graph this 12 minus 2 to the X, subtract 16, and see where that equals 0. Anytime it asks me to solve an equation, I'm probably going to graph it. And when it's equals, we know on Desmos it's not going to work exactly with our testing version, so you do need to put that minus in there. Looks like 4 is where it crosses the x-axis, so 4 would be our answer. I do want to caution you to look at C. If your answer did not show up here, you could just put that in Desmos to see what the choice is to match it up. Alright, number 14. The antler spread and shoulder height of an adult male American elk are related by the model given there. So this equation. Find the shoulder height of a male with an antler spread of 55. Alright, it tells me the antler spread is the A, and A is 55, so that means I'm just going to put a 55 right there, and I want to solve for H. So I'm going to put 116 log 55 plus 40 minus 176. That's going to give me the height. And I can just put that straight in there. 116 log 55 plus 40 minus 176. And that gives me 53.4 inches, which is A. All right, next, our question is asking us to find the inverse of a function. When you find an inverse, you take y, make it x. You take x and make it y, and you solve for y. So I'm trying to get y by itself. I'm going to subtract 2 on both sides. And then I'm going to divide everything by -3. This is one way to write it, but if you'll look at the choices, you'll notice that is not there. So another way to do it is to take that -3 and divide it by each one. You'll notice that means it's not C. This one doesn't have an X, so it's one of these. So it must be this one. What that happened is that we've put our X to the side. The 2 negatives have now made a positive, and so that's our answer. Now, I do want to remind you that you could graph the original equation, and you could graph our answer choice. And what we're looking for is for the graph to be able to flip over y equals x. Does it look like it is a reflection on y equals x? It does. So that makes sense that that answer would be correct. All right, now we're on to some circles. In circle O, AD, which is the arc here, is 120, BC is 30, and it wants me to find this angle right here. Alright, whenever you have some angles like that that are not necessarily from the center, what you do is you take 1/2 and you add the 2 angles outside of that together. So you multiply that by 1/2. This will give you 200, and unfortunately there's nothing in Desmos I can do there. Well, it's 1/2 times 200, I'm sorry. And so our answer is C. Number 17. Alright, we've got this picture here. Whenever we see that perpendicular right there, that tells me it's probably a bisector. And so I know that this and this are equal. I know those 2 arcs there are congruent. Let's see what it says. BCD is a major arc. Not necessarily. We don't know anything about those angles except that one's 90, and it's not inscribed or central. BAD is a minor arc. Well, that looks really big, so I don't think that's a minor arc. AC is a diameter. Maybe. Let's check and see what else it says. CD is congruent to BA. It doesn't look like it is, so it's probably not that one. So our answer choice is the diameter, and that's one of our rules. It was one of the theorems that we have discussed. Number 18. What is the radius, or what is the equation whenever this is the radius and center of the circle? Whenever you have the center, you change the sign. So if it's a 4, we're looking for -4. So not that one. It's a -3, so I need a +3. So not that one. And then the radius is 2. You have to square the 2. 2 squared is 4, so it must be B. So you change the 4 to a negative. You change the 3 to a positive, and then you square the 2, and 2 squared is 4. Just a reminder that you can also continue with graphing in Desmos. We're going to graph that choice that we chose just to compare. Press home because that circle looked really small. And now that makes sense because 4, -3 is the center, and it does look like it has a radius of 2. So you can graph those to look at those and help you. Alright, next our question is to figure out which one matches the graph. Alright, the first thing I can tell is I can tell that the amplitude is 2. Because it's -2 to 2, so I know the amplitude is 2. So there must be a 2 on the out front. And there is on all of them. Alright, I can also tell that it's going to be sine because it's starting at 0. So it's not going to be cosine. So it's one of these 2. Looks like 1/3 is going to be in there. The question is it -2 or +2? Sine is going up. That's the normal way to write it, so it must be the positive one. Again, we can graph this in Desmos to check our work. So we would have 2 sine 1/3 x. Alright, we do need to check and make sure we're in radians. Now we are. And although it looks different, we can sort of figure out that that would be correct. That's going up to 2 and down to 2. You can see that on the range. The 12 pi, I would have to come way out here. Let's see, 1, 2, it's 2 cycles is 2 pi. So it would be around right in there. And notice that does say 12 pi crosses the x-axis there, so that is correct. Alright, number 20. It's asking me to find x. This is a right triangle trig kind of problem. We know this side, 9 is opposite. Hypotenuse is across from the 90. Other side is adjacent. So that means that we have opposite and adjacent. That's SOHCAHTOA, which means tangent of 20 equals 9 over x. I'm going to put that over 1. Cross multiply. X tangent of 20 equals 9. Divide by tangent of 20. So in Desmos, I will put 9 divided by tangent of 20. Make sure we're in degrees in a problem like this. It does change our answer greatly. We do get 24.7. Lastly, we want to convert this degrees to radians. So we would have 320. What you do is you multiply by pi over 180. A lot of times we just divide it by 180 and then just put the pi with it. So in Desmos, 320 divided by 180. Change that to a fraction. So that's 16 over 9 with a pi. So that looks like our answer choice would be A.